The metal groaned softly in the Aleutian wind, a sound so faint that Lieutenant William Thies almost missed it beneath the crying of distant gulls. His boots squelched through tundra moss, still wet from the previous night's rain, each step bringing him closer to the impossible shape half buried in the island's eastern slope. The rising sun emblem on the tail, though scarred by impact and weathering, remained unmistakable even at 100 yards. A Japanese Zero fighter, largely intact, rested in the volcanic soil like a mechanical corpse waiting for autopsy. Thies had joined the Navy 2 years earlier, had survived Pearl Harbor's chaos, had watched friends vanish into the Pacific's cold depths. He had learned to hate these aircraft with the intensity that only comes from helplessness, from watching them dance through defensive fire as though mocking the laws of physics themselves. Now one lay before him, vulnerable and silent, its secrets exposed to anyone with the patience to read them. The discovery came on June 10, 1942, though the crash itself had occurred nearly a month earlier. Petty Officer Tadayoshi Koga, flying cover during the Japanese attack on Dutch Harbor, had taken ground fire that severed his oil return line. The engine, starved of lubrication, seized gradually rather than catastrophically, giving Koga time to select what appeared to be a suitable landing site. What he could not see from altitude was that his chosen field was actually a swamp, its surface deceptively solid-looking from above. The wheels touched down smoothly, then immediately sank, flipping the Zero onto its back with enough force to snap Koga's neck instantly. The aircraft, cushioned by soft earth, survived the impact largely undamaged. Koga's body remained strapped in the inverted cockpit for weeks before American patrols finally located the crash site. By then, carrion birds had reduced him to bone and uniform. The machine that killed him, however, waited in nearly pristine condition for examination. Within hours of Thies's radio report, the wreckage site transformed into something resembling an archaeological dig conducted at military speed. Engineers arrived by seaplane and transport, bringing cameras, measuring instruments, and notebooks already filled with questions accumulated through months of desperate combat. They approached the Zero with a mixture of professional curiosity and something approaching reverence, the way one might approach a predator's corpse, respectful of the danger it represented even in death. Captain James Harrigan, leading the technical assessment team, had lost his younger brother to a Zero near Midway just 3 weeks earlier. He stood before the exposed engine cowling, fighting the urge to strike the metal, to somehow punish the machine for crimes committed by dozens like it. Instead, he photographed every visible component, measured every accessible dimension, and recorded observations in handwriting that remained steady despite the fury burning beneath his professional demeanor. The first shock came within minutes of beginning the detailed examination. Harrigan ran his hand along the fuselage skin, expecting to feel the reassuring thickness of proper armor plating. Instead, his fingers detected metal so thin that firm pressure caused visible flexing. He pressed harder, watching the aluminum dimple inward like a dented can. Sergeant Harold Katz, an aircraft mechanic who had serviced Wildcats and Dauntlesses for 18 months, joined him in the tactile examination. His face, normally weathered into an expression of professional skepticism, went pale as understanding dawned. "This is lighter than our fuel tank material," he said, his voice carrying disbelief that bordered on accusation. "There is no armor here at all. None. Not behind the pilot, not around the fuel tanks, not protecting the engine. Nothing." The two men exchanged looks that communicated what words could not quite capture, a mixture of horror, incomprehension, and the dawning realization that their understanding of their enemy had been fundamentally, dangerously incomplete. The Americans had constructed elaborate theories to explain the Zero's combat effectiveness. Some intelligence analysts suggested revolutionary metallurgy, Japanese superalloys that combined impossible strength with minimal weight. Others proposed advanced structural engineering, hidden internal bracing that provided protection without obvious bulk. A few whispered about captured German technology, imagining collaborative Axis programs that produced fighters superior to anything the West could field. The truth, laid bare beneath Aleutian skies, was simultaneously simpler and more disturbing than any theory. The Japanese had built an aircraft that prioritized performance over protection so absolutely, so completely, that it challenged fundamental Western assumptions about military engineering. Every unnecessary ounce had been eliminated with surgical precision, creating a fighter that could outmaneuver, outclimb, and outrange anything in the Pacific theater. The cost of that performance stared back at them from every unarmored surface, every exposed fuel line, every structural member shaved to minimum tolerance. The Zero was magnificent, and it was a death trap, and those qualities were inseparable. Cats, crawling beneath the inverted fuselage to examine the belly structures, found fuel stains around the tank mountings. The rubber bladders that held the Zero's gasoline supply showed no evidence of self-sealing technology. The foam-lined tanks that allowed American aircraft to absorb bullet strikes without immediate catastrophic failure. A single incendiary round entering these tanks would ignite the fuel instantly, creating a fireball that would consume the aircraft and its pilot within seconds. American pilots had reported this phenomenon countless times, Zeros exploding with shocking violence from what seemed like glancing hits, but they had attributed it to battle damage striking ammunition stores or oxygen systems. The reality was more prosaic and infinitely more terrible. Every Zero carried 130 gallons of high-octane gasoline in containers no more resistant to puncture than a carnival balloon. Japanese pilots flew these machines knowing that any hit to the fuel system meant certain death, a fact that rendered their aggression in combat not reckless, but quietly, desperately courageous. The examination continued through the afternoon, each new discovery adding layers to a picture that grew more complex and more disturbing with every measurement taken. The seat offered no protection whatsoever, just a thin pad over a lightweight frame. Where American fighters incorporated steel plates thick enough to stop rifle-caliber bullets, saving countless pilots from spine and skull injuries, the Zero's pilot sat exposed to fire from any angle. The canopy glass, when Harrigan measured it with calipers, proved to be standard thickness, offering protection from wind and cold, but none from enemy rounds. Even the instrument panel, normally backed with armor in American aircraft, consisted of thin aluminum, easily penetrated by fragments or small arms fire. The cumulative effect of these absences created an aircraft that offered its pilot virtually no margin for error, no second chances, no forgiveness for tactical mistakes or simple bad luck. To fly the Zero in combat was to accept that survival depended entirely on never being hit, an assumption that combat experience had already proven catastrophically optimistic. Lieutenant Commander Eddie Sanders arrived at the crash site on the second day of examination, summoned from his posting at Kodiak specifically to provide a combat pilot's perspective. Sanders had engaged Zeros on 4 separate occasions, surviving through a combination of skill, luck, and the structural toughness of his Wildcat, which had absorbed damage that would have destroyed lesser aircraft. He approached the wreckage with the careful attention of a man confronting a recurring nightmare made physical. The Zero was smaller than he had imagined, more delicate, almost fragile in appearance, now that it lay still and broken rather than screaming through combat maneuvers. He climbed into the cockpit, settling into the seat that Koga had occupied during his final minutes, and began a systematic assessment of the controls and layout. What he discovered there challenged his understanding of aerial combat even more profoundly than the lack of armor had challenged the engineers. The control stick, when Sanders gripped it experimentally, felt impossibly light. In American fighters, stick forces increased with airspeed, requiring significant pilot strength to execute high-speed maneuvers. The Zero's controls remained feather-light across its performance envelope, responsive to the slightest input. Sanders moved the stick through its full range of motion, feeling resistance so minimal that an American pilot accustomed to heavier controls might easily over-control the aircraft, applying too much aileron or elevator and either departing controlled flight or exceeding structural limits. The lightness was deliberate, designed to allow Japanese pilots to execute the rapid, precise control inputs necessary for the Zero's legendary maneuverability. But it demanded a level of touch and training that took years to develop, a fact that explained why Japanese pilot training programs were so lengthy and intensive compared to American equivalents. The aircraft forgave nothing, rewarded perfection, and punished any lapse with immediate, often fatal consequences. Sanders examined the gun sight, the throttle quadrant, the mixture and propeller controls. Everything was positioned logically, within easy reach, designed for efficient operation. The Japanese engineers had clearly thought deeply about pilot workload and ergonomics. But they had thought within a completely different framework than their American counterparts, one that assumed pilots would be elite specialists who had mastered their aircraft through thousands of hours of training, rather than the steady stream of replacements that American doctrine anticipated. The Zero was a virtuoso's instrument, requiring virtuoso skill to exploit its capabilities without being killed by its vulnerabilities. American fighters, by contrast, were designed to be effective in the hands of pilots with basic competence, protecting them during the learning curve that combat inevitably demanded. Neither approach was wrong in abstract terms, but only one proved sustainable in a war that consumed pilots as rapidly as it consumed fuel and ammunition. The engine examination revealed another dimension of the design philosophy. The Nakajima Sakai radial engine, 14 cylinders arranged in 2 rows, produced 940 horsepower at takeoff, significantly less than the Pratt & Whitney engines powering American fighters. Yet the Zero climbed faster and operated effectively at higher altitudes than its American opponents. The answer lay not in the engine, but in everything around it. The entire aircraft, fully fueled and armed, weighed 5,500 pounds, nearly 2,000 pounds less than a comparable American fighter. Power-to-weight ratio, the critical determinant of climb rate and acceleration, favored the Zero dramatically despite its less powerful engine. Japanese engineers had achieved through weight reduction what American engineers sought through raw horsepower, an elegant solution that worked magnificently until combat damage disrupted the careful balance between performance and structural integrity. Captain Harrigan, compiling his preliminary report by lantern light that evening, struggled to articulate what the day's examination had revealed. The technical details were straightforward enough, measurements and weights and material specifications that any engineer could verify. But the implications of those details reached beyond technical assessment into questions of military philosophy, cultural values, and the fundamental assumptions that shaped how nations waged war. The Zero represented a coherent vision of aerial combat, one that emphasized individual skill, aggressive tactics, and acceptance of high casualties in exchange for combat effectiveness. American doctrine, shaped by different historical experiences and cultural values, emphasized survivability, sustainability, and the recognition that trained pilots represented irreplaceable assets worth protecting even at the cost of some performance. Neither side had consciously articulated these philosophies. They had simply built aircraft according to priorities that seemed self-evident within their respective contexts. The collision of these philosophies in Pacific skies had produced a bloodbath that neither side had anticipated. The following weeks saw the Akutan Zero carefully dismantled, each component tagged and cataloged before being crated for shipment to Naval Air Station North Island in San Diego. There, the aircraft would be reassembled and subjected to exhaustive flight testing, providing American pilots and engineers with unprecedented insight into its capabilities and limitations. But even before those tests began, the initial examination had yielded intelligence valuable enough to alter tactical doctrine throughout the Pacific Fleet. Bulletins circulated through every Navy and Marine air unit, detailed reports that described the Zero's construction and drew explicit conclusions about how to fight it effectively. The lightweight construction that enabled its maneuverability also imposed severe limitations at high speeds. Above 300 miles per hour, the Zero's controls stiffened dramatically as aerodynamic loads increased. robbing the aircraft of the agility that made it deadly at slower speeds. American fighters, though less maneuverable at low speeds, could dive away from Zeros at velocities the Japanese aircraft could not safely match without risking structural failure. New tactical doctrine emerged rapidly, disseminated with an urgency that reflected hard-won respect for the Zero's capabilities. Never attempt to turn with a Zero in level flight, the bulletins warned. Use altitude advantage to dive, attack, and disengage before the Zero can bring its turning ability to bear. Avoid prolonged engagements at low speed and low altitude where the Zero dominates. Instead, maintain energy advantage through speed and altitude, converting those advantages into brief, violent attacks that exploit the Zero's lack of protection. A single burst of .50 caliber fire into an unarmored Zero could prove catastrophic, igniting fuel tanks, destroying unprotected control systems, or killing the pilot directly. The key was landing that burst without entering the turning fight where the Zero reigned supreme. It was a doctrine that required discipline, patience, and the willingness to disengage, even when every instinct screamed to pursue an enemy who had killed your friends. But it worked. The Zero's ammunition capacity revealed another critical vulnerability. Engineers counting the remaining rounds in the Akutin aircraft discovered that it carried just 60 rounds per 20mm cannon and 700 rounds per 7.7mm machine gun, approximately one-third the ammunition load of comparable American fighters. This limitation forced Zero pilots into a tactical dilemma. To ensure hits with limited ammunition, they needed to close to point-blank range, exposing themselves to defensive fire and reducing reaction time to fractions of a second. The aggressive close-range attacks that American pilots had observed were not merely cultural preference, but operational necessity, driven by ammunition constraints. Every design choice cascaded into tactical implications, and understanding those cascades provided American tacticians with exploitable advantages. A Zero with empty guns was merely an unarmored target, and forcing Zero pilots to expend ammunition through defensive maneuvering became a viable tactical approach. Maintenance crews examining the airframe's construction found evidence of hand-fitting and individual craftsmanship that fascinated and troubled them in equal measure. American aircraft rolled off assembly lines with standardized parts and interchangeable components, allowing rapid production and field repairs using pre-manufactured spares. The Zero before them showed signs of custom work, panels hand-fitted to achieve flush joints, components individually adjusted to minimize drag and weight. Each rivet had been countersunk with care, each seam smoothed to reduce aerodynamic penalties. It was beautiful in a way that mass-produced American fighters were not, reflecting a cultural aesthetic that valued precision craftsmanship even in military hardware. But that beauty came at devastating cost. Zero production rates never approached those of American factories, and field maintenance required skills and time that frontline units increasingly lacked as the war progressed and experienced personnel were lost to attrition. By autumn 1942, restored Akutan Zero began flying against American fighters in carefully controlled tests above San Diego. Test pilots, initially cautious, grew increasingly confident as they learned the captured aircraft's characteristics. In turning fights below 200 knots, the Zero dominated completely, requiring only two-thirds the radius of any American fighter to complete a full circle. But above 300 knots, the tables reversed dramatically. The Zero's lightweight structure and fabric-covered control surfaces created aerodynamic forces that the pilot could barely overcome, while American fighters maintained control authority well beyond 400 knots. Mock combat sessions demonstrated that disciplined American pilots using proper tactics could engage Zeros with relative safety, exploiting speed and structural strength to dictate engagement terms. The mystique that had surrounded the Zero, the aura of invincibility built on early combat successes, evaporated when exposed to systematic analysis and testing. Intelligence analysts studying the Zero, in conjunction with prisoner interrogations and captured documents, began assembling a comprehensive picture of Japanese naval aviation doctrine. The Zero had been designed during the mid-1930s, when air combat theory emphasized maneuverability and pilot skill above all other factors. Japanese planners, preparing for a war they expected to be brief and decisive, had optimized their primary fighter for the opening campaigns, assuming that superior training and aggressive tactics would deliver rapid victory. The long attrition war that actually developed had not been part of their planning calculus. As elite pre-war pilots were killed and replaced by less extensively trained personnel, the Zero's demanding flight characteristics and lack of protection became liabilities rather than acceptable trade-offs. The aircraft that had terrorized Allied forces in 1941 and early 1942 grew progressively less effective as 1943 advanced, not because the Zero itself had changed, but because the context of its employment had shifted beneath it. American factories, operating at capacities that Japanese planners had considered impossible, began producing fighters specifically designed to counter the Zero's strengths while exploiting its weaknesses. The Grumman F-6F Hellcat emerged as the ultimate expression of this counter-Zero philosophy, an aircraft that sacrificed some low-speed maneuverability for robust construction, heavy armament, and the kind of high-speed performance that allowed pilots to engage or disengage at will. Hellcat pilots were taught to think of their aircraft as flying tanks, capable of absorbing damage that would obliterate a Zero, while dealing out punishment through 6 50-caliber machine guns that could tear apart lightweight Japanese structures with devastating efficiency. By mid-1943, the Pacific Air War had fundamentally shifted. Zero pilots who had once hunted American fighters with near impunity found themselves hunted in return. Their aircraft's vulnerabilities transformed from theoretical concerns into immediate threats to survival. Zero engineers, aware through combat reports and their own analysis that the Zero's lack of protection had become critical, attempted to address the deficiencies in later variants. They added minimal armor plating behind the pilot seat and around critical engine components, incorporated partially self-sealing fuel tanks, and strengthened some structural members. But each addition degraded the performance that had made the Zero formidable. With armor and protected fuel tanks, the Zero could no longer outturn American fighters decisively, yet remained too lightly built to survive prolonged combat. The design had been optimized so completely for a specific set of parameters that any deviation compromised its fundamental nature. It was a dead end, a brilliant answer to a question that combat experience had revealed to be incorrectly posed. The Americans had asked how to build a fighter that could survive errors, protect pilots through the learning process, and maintain effectiveness even when damaged. The Japanese had asked how to build a fighter that could dominate through superior maneuverability. Both got exactly what they asked for, but only one question proved relevant to the war that actually unfolded. The captured Zero toured American facilities throughout late 1942 and into 1943, a teaching tool more valuable than any training film or tactical manual. Pilots rotating back from Pacific combat zones were given opportunities to examine it, to sit in the cockpit, to touch the thin aluminum, and understand viscerally why their gunnery had proven so devastatingly effective when they managed to land hits. Many reported complex emotions. Respect for the aircraft's elegant engineering mingled with horror at the calculated callousness of a design that offered pilots virtually no protection. Some Japanese pilots, they learned through interrogations, had taken to wearing privately purchased steel breastplates or armor scavenged from damaged aircraft, improvised protection that spoke volumes about their understanding of the Zero's vulnerabilities. The official doctrine emphasized attack and maneuver, never presenting defense as necessary because proper tactics should prevent the enemy from achieving firing position. Reality, as it so often does, had proven less accommodating than doctrine suggested. Captain Harrigan, promoted and transferred to a training command, incorporated lessons from the Zero examination into every syllabus he designed. New pilots learned Zero capabilities and limitations before ever seeing combat, understanding that the graceful aircraft that could outturn anything in the sky would explode like a firework if properly hit. They learned to respect the Zero's maneuverability while understanding that respect did not equal fear, that knowledge of an opponent's capabilities included knowledge of vulnerabilities. The mystique dissolved, replaced by tactical clarity. A Zero was an extremely capable aircraft flown by often highly skilled pilots, but it was not supernatural, not invincible, not proof of Japanese technical superiority. It was a machine built according to a specific philosophy, brilliant within that philosophy's constraints, vulnerable where those constraints created weaknesses. Understanding that distinction saved lives. By 1944, most early Model Zeros had been destroyed in combat or relegated to training duties in Japan. Newer fighters attempted to balance protection with performance, but none recaptured the original Zero's combination of capabilities. The mathematical certainty of attrition had asserted itself. Japan's limited industrial capacity unable to replace losses at rates even approaching American production. More critically, Japan's pilot training pipeline had collapsed under the weight of combat attrition and fuel shortages, replacing experienced aviators with poorly trained replacements who lacked the skills to exploit the Zero's demanding flight characteristics. American pilots, flying aircraft designed around lessons learned from the Akutan Zero and equipped with tactical doctrine derived from exhaustive testing, achieved kill ratios that would have seemed fantastical in 1942. The captured fighter had provided a roadmap to victory, but following that map required understanding that the enemy operated from fundamentally different premises about warfare, technology, and the value of human life. The thin aluminum skin that had shocked Lieutenant Thies became, in retrospect, the most honest statement Japanese engineers could have made about their design priorities and constraints. They had created a weapon system that maximized combat effectiveness within severe limitations, accepting horrific vulnerability as the price of superior performance. It was brilliant and it was terrifying, a machine that killed its pilots as reliably as it killed their enemies. The Americans learned from it, adapted to it, and ultimately rendered it obsolete not through superior engineering alone, but through superior doctrine supported by sustainable training and production systems. The Zero remained dangerous until the war's end, but it was no longer mysterious, no longer the invincible specter that had haunted American nightmares. It was just an aircraft, exceptionally capable in specific circumstances, fatally vulnerable in others. Flown by men who deserved respect for their courage, even as the machine that carried them proved increasingly inadequate to the demands placed upon it. The engineers who first examined the Akutan Zero understood immediately that they faced something beyond captured equipment. They were confronting an entire military philosophy made tangible, every absent armor plate representing a choice, a calculation that valued range and maneuverability over survivability and sustainability. Those choices had enabled Japanese naval aviation to dominate Pacific skies in the war's opening phase, allowing relatively small numbers of elite pilots to achieve results far exceeding their numerical strength. But those same choices ensured that as pilots were lost, as American forces developed effective counterattacks, as Japan's industrial limitations prevented rapid replacement of losses, the Zero's advantages would erode faster than its vulnerabilities could be addressed. It was optimized for swift, decisive war, not grinding attrition. The Pacific delivered attrition instead, and the Zero, magnificent as it was, could not adapt to that reality. Standing in California sunshine, watching test pilots demonstrate the captured Zero's capabilities against American fighters, Captain Harrigan reflected on the strange intimacy of understanding enemies through their machines. The Zero told stories its designers never intended, stories about resource constraints, about cultural assumptions, about brutal mathematics of production and training that transcended individual courage or skill. It reflected a nation's strengths, its aesthetic sensibilities, its warrior traditions, and simultaneously exposed its desperate gambles, its industrial limitations, its willingness to spend lives in pursuit of victory. The Americans had built fighters to bring their boys home alive. The Japanese had built theirs to achieve tactical dominance through technical excellence. Both philosophies had merit within their contexts, but only one proved sustainable across years of attrition warfare. There was no triumph in that knowledge, only cold recognition that conflicts were decided less by superior weapons than by superior logistics, training systems, and philosophical frameworks that could adapt to realities that always, inevitably, diverged from pre-war assumptions. The legacy of the Akutan Zero extended decades beyond the war itself. It represented perhaps the single most valuable intelligence coup of the Pacific Campaign, a windfall that saved thousands of American lives by revealing vulnerabilities that might otherwise have required years of bitter combat experience to discover. But it also served as a reminder of how profoundly enemies could misunderstand each other. It was masterful within those constraints. That it was also inadequate to the war that actually developed reflected not failure, but the impossibility of perfect foresight, the chaotic unpredictability that characterizes all human conflict. The Zero's lack of armor was neither mistake nor monstrosity. It was the logical conclusion of a design philosophy that circumstances would ultimately invalidate, but which had seemed not merely reasonable, but necessary when the aircraft first took shape on drawing boards in the late 1930s. Continue exploring the quiet contradictions that define humanity's darkest hours.